we will start off with an Algebra 1 review warm-up. So I would like for you to answer question number 1 and question number 2. Go ahead and push pause, read it, answer the questions, and we'll go to the next slide to see the answers. Question number 1. What's the domain? Well, the domain will be the x values. So you see 2, 4, 3, 5, 4, 5. Here we put it in order from least to greatest, and that would be 2, 3, 4, and 5. We see a 4 here and a 4 here. We don't have to write it twice. Writing it once states that it's in the domain. Take a look at your range from least to greatest, -1, 1, 2, and those are your y values, -1, -1, 2, 1, 2, 2. Is it a function or not? No. Why? We have duplicated x values. Now that's something we'll look at a little later, but here it is definitely an Algebra 1 review, so I brought it up at this time. Question number 2. X is less than 6. And in interval notation, it would go from -infinity all the way to 6. So we always start at the smallest value and go to the largest value. The next one reads 2 is less than or equal to x, which is less than 5. In interval notation, we would start at 2, close bracket, and go to 5. We know that the domain will be your x values, which represent corresponding values of the y that exists. Look at the notation here. Y is equal to f of x. So sometimes you'll see your functions and it will state y is equal to x plus 3. Or we can rewrite it as f of x is equal to x plus 3. And it just means the same thing. Range of a function, that will be your y values. Y is equal to f of x. They're interchangeable, so you may see your functions that begin with y, and then we may see them that begin with f of x. What I want you to think about when you're looking at your domain, your x values go from left to right, smallest over to largest. When you think about your range, it's along the y-axis, and we start at the smallest one, the least, and go up. So that's how we'll write it in interval notation. So here's an example. Find the domain and range of the function f of x is equal to the square root of x plus 3 from its graph. So when we take a look at this here, that actual function, if you were to go ahead and put it in your calculator and graph it, it would start right here at -3, and it would continue to go this way with an arrowhead. So if we want to find out what the domain is, we're going to look at it against the x-axis. So against the x-axis right here, here's my little measuring stick. It actually has a starting place, which is -3, and as I travel along the x-axis to go in the direction of this function, it just keeps going. Is that right? Yes, it does. And so we would say that the domain is -3 to infinity. So it starts here and it continues in this direction. We also can write it in set notation. So you'll see set notation like this: x values such that all the x values should be greater than or equal to -3. So we need to be able to go from interval notation to set notation and read it either way. Now, as we take a look at the range, we measure the range along the y-axis. We go up and down the y-axis. So I'm going to go over here to the y-axis. At the y-axis, my function starts right here and it continues to go up, because here is my function, and as you can see, it is rising. Okay, and even though it is rising in this direction, I'm measuring it against the y-axis. So it starts here at 0 and it continues to go up. So the range is 0 to infinity, or we could write it y values such that y values are greater than or equal to 0. So here we have example number 1. This is a function. You can see it as a curve, and then we have a straight line going down and a line going up. So we want to check the domain. When we look at the domain, we're looking at this function along the x-axis. We want to start at our smallest x. Over here, you can clearly see that there is an arrowhead there. So anytime you have an arrowhead, I would suggest that you circle the arrowhead because that means it continues to go in that direction. So if that is the case, the x values here, they don't stop. Okay, let's go in the other direction. The other direction, we're going, and take a look. We have another arrowhead, which means it keeps going. Therefore, our domain is going to be from negative infinity to positive infinity. Sometimes you will see the domain written like this, which means all real numbers. Let's take a look at our range. Our range we measure against the y-axis. So I'm just going to go and travel up and down the y-axis. Here at the y-axis at -3, if I were to go over, this function starts measuring against the y-axis at -3. Do I see this function below -3 or above -3? Well, it's above -3. So I start at -3 and I go up, 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 up. And what I notice here, even when I get here and I think this function ends, it doesn't, because there's an arrowhead pointing up, which means this function continues to go upward. Therefore, the range is from -3, the starting place, to infinity. Because we use our graphing calculators in this class. If you were to graph a function and it looked like this on your calculator, you would not see the arrowheads, but know that they are there. So they're your arrowheads. So when we think about the domain, we measure it against the x-axis, along the x-axis. If I clearly see this function, it continues to grow and grow. So it continues in this direction and it continues in this direction because these arrows will stretch, 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 stretch like that. So the domain is negative infinity to positive infinity, or all real numbers. When I look at the range of this function, I am measuring this function against the y-axis. We start at our lowest value and we'll go to our highest y value. Well, I can clearly see that this function here stops right here at 1, 2, 3, 4. Okay, so my lowest value is going to be down here at negative infinity because I see these arrowheads, which means it's going to keep going, and I go up, 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 up until I get here. So my range is negative infinity to 4. Remember, the range we measure against the y-axis. Here we have example number 3. We want to look at the domain. We start at the x-axis and we stay on the x-axis and we try to see what's the smallest value of x for this function. And what I see is that my smallest value starts right here, and then what happens, we have arrowheads, which means it continues to go in this direction. So my domain starts at 0 and goes to infinity. Well, when I take a look at my range and I measure my range against the y-axis, this function has arrowheads, so it's going to continue to grow, or go in those directions. So will I be able to see a starting and a stopping place along the y-axis? Absolutely not, and therefore the range of the function is negative infinity to positive infinity. So let's give it a second and you figure out what the domain is of this function and what the range is. Well, the first thing I want to do is I went ahead and put my arrows on this function to show that it continues in these directions. So when I think about my domain, I measured the domain against the x-axis. How far out will this graph go? Where it has arrowheads, so it's going to continue. And so in that direction, there's no bound. And in this direction, it definitely continues. So let's see what our domain is. And our domain is negative infinity to positive infinity. Now, let's take a look at the range. The range we measure against the y-axis. We want the smallest y value to the biggest y value. And if we can't see what that is because of an arrowhead, we know it's going to have infinity in it. So when I take a look at this function and I'm here on my y-axis, voila, it starts right here at 2. What happens at 2 is that my smallest value or my biggest value, Well, it's my smallest value because this continues to grow. It continues to go up. So my range is going to be 2 to infinity. You find the domain and range of this function that was graphed in the calculator. Okay, for this function right here, we can see that it stops right here, but in our other direction, it goes off the side of the screen of the calculator. So on this side right here, we will put our arrowhead because it's going off the side of the calculator screen. And over here, we put a dot because it stops. So let's see what our domain is. Well, our domain is negative infinity to 3. Well, why negative infinity? Because we read our graphs from left to right. And along the x-axis, the smallest value, take a look, that arrow keeps going. It's going to be from negative infinity, and then it's going to travel until it gets here to 3. Let's take a look and see if you got the range correct. Look at that. The range is 1 to infinity. So it starts along the y-axis at 1, and it goes up to infinity. Welcome to the domain and range video lesson.